the second law of motion, or the law of force. In the previous section, we realized that objects will be stationary or moving at constant speed if the forces acting on them are balanced or zero. It follows that a change in the velocity of the object, whether it is its speed or direction or both, needs an unbalanced force to act on the object. A change in the speed or direction of a moving object is known as acceleration. We have also noted in the previous section that changing the state of an object with higher inertia needs a greater force and vice versa. This means that there must be some way to describe the mass and velocity of an object in a single quantity, since a change in either mass or velocity is changing the state of the object. This quantity is known as momentum in physics. Mathematically, momentum is equal to mass times velocity. So it has both a magnitude and a direction. So it is a vector. If you change the direction of an object, its momentum will change. If you change the speed of an object, the momentum will change. Let us consider a case where we are pushing a ball from rest. When we give a small push to the ball, assuming very low friction, the ball begins to roll slowly. If we were to apply a harder push, the ball accelerates to a higher velocity. If the push is applied continuously, the ball will continue to accelerate. It will gain in velocity. Remember, we are neglecting friction here. Thus, it seems that the force applied on the object is directly proportional to the rate of change of its momentum. If the momentum changes quickly, the force applied is greater. This relationship between the rate of change of momentum and the force applied on the object can be expressed mathematically. Momentum is symbolized by the letter small p. A change in momentum between two states is given by the expression p2 minus p1. Since we regard the mass as being constant in this case, the change in momentum is brought purely by a change in velocity. So p2 minus p1 can be regarded as mv minus mu, where v is the final velocity and u is the initial velocity, or m bracket v minus u. Thus, a change in the momentum over a period of time can be given by the expression m bracket v minus u divided by t. If you recall what we have done in the previous chapter, you will know that this quantity v minus u divided by t tells us the rate of change of speed, which we otherwise know as acceleration. So in other words, we can say that the change in momentum is mass multiplied by acceleration. And this gives us a very useful and fundamental result in physics. The force applied on an object is equal to the object's mass multiplied by the object's acceleration in response to that force. In standard units, force is measured in newtons, and 1 Newton of force will cause an acceleration of 1 meter per second squared in an object of mass 1 kilogram if the force was applied for a second. In real life, we observe that a sudden braking of a vehicle or the sudden stopping of a cricket ball with our hands, or a collision where a vehicle comes to a stop very quickly, causes greater pain and damage. This is because when the speed changes suddenly, that is, in a very small interval of time, the rate of change of momentum is large and consequently the forces involved are much greater. This is why fielders try to move backwards with the ball in order to stretch out the slowing of the ball in time. This reduces the average force exerted by the ball on the hands. Let's try to solidify our understanding of this concept with a simple problem. Let us say that we have an object of mass 1 kilogram that is initially moving at a speed of 5 meters per second in the north direction. A force is applied on this object, and in a period of 5 seconds, the new speed of this object is 10 meters per second in the north direction. What is the force applied? Well, based on the information that we have been given, the final velocity of this object is 10 meters per second in the north direction, that is v. The initial velocity of the object was 5 meters per second in the north direction, that is u, and the mass of the object was 1 kilogram. Given that it took 5 seconds for this change to happen, We can put these values in the equation and calculate the force applied in this time, as you can see. So we can summarize what we have learned as follows.